So the third segment of the first lesson in chapter 6 is this concept of regions bounded by the y-axis. And I'm only going to do one example of this today because there's not going to be a whole lot of it in the homework. But what it really boils down to is, what if I asked you to find the area of this region? In our past two videos, we've sort of talked about this idea of, oh yeah, you just, kind of take the integral of the top function and yeah, you win. But in this problem, it's like we don't even have a concept of a top function. It's like, there isn't even a function here. And then you're kind of like, well, this one's on top, but then the same one is on the bottom. Like, what the heck is this? And what I want us to recognize is that this is a region that's bounded by the y-axis. Instead of thinking about this problem, all of our previous problems have been, here's a function, and here's the area between that and the x-axis. You'll notice even when I did my shading for this problem horizontally, almost as if to say, this is the function, and this is the bottom boundary. I almost want to tell you to turn your head to the right by 90 degrees so that you're looking at sort of a normal looking function. And the reality is that we're allowed to do that so long as our function is in terms of y. And to be honest, this function, you guys are looking at this saying this isn't even a function. It can be a function if I write it as x equals, so not y equals, but x equals, and say x equals y cubed minus 2y plus 2, right? And so the idea is, if we think about this function, instead of plugging in x values and getting y values, instead plugging in y values and getting x values, this is now a function. It passes the horizontal line test, right? So what I'll need to do here is take the integral of the function that I'm looking at, y cubed minus 2y plus 2 dy, and that means my boundaries, this lower bound and this upper bound, will be y equals boundaries. And so the question is, where does this region start and stop? And I could imagine some people would say, oh, it starts at 0 and ends at, 3 something. But notice, those are x values. I don't want to know where it starts and stops with respect to x. I want to know where it starts and stops with respect to y, right? So this graph starts down here somewhere and ends up here at 1. Right? And this isn't a problem I'm going to evaluate. I'm not, I'm already long on the lessons today. I just want us to have a sense of the fact that these problems can be set up this way. So even if I was just estimating, we can look at this. This is, almost almost negative 1.8, and it goes up to this value of 1. Could we find out what this exact value is? Sure, we could use a calculator to find that, but at the moment I'm just looking at this concept of, do we understand that that integral would find the area of that region? So in the homework tonight, I might have a few of those where you'll set them up. And the whole idea is, if you notice that your region is bounded by the y-axis, it may be valuable to think about this function in terms of y instead, and use y bounds instead of x bounds. So make sure you download the assignment, look at a couple of problems, make sure you've got a sense of it before you get to class tomorrow, and I'll see you then.